Hello everyone. Today I am going to discuss the last problem of Leetcode Biweekly contest 149, which is minimum cost good operation. So what is the problem? We are given a string caption of length n. A good caption is a string where every character appears in a group of at least three consecutive occurrences. So let's say A, B, B, B. Here A appears in a consecutive of three characters A, and similarly B appears consecutively at three times. So these are good options, but A, B, 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 here A appears only two times, so this is not a good caption. Okay, now what we can do, we can perform the following operation any number of times. So we can reduce the value of caption any ith index by 1, or increase the value of the ith index by 1, or we can move to the previous character, or we can move to the next character in one operation. So what we have to do, we have to make the given caption a good caption, and also uh, if it is not possible, we have to return empty string. Okay, and if there are multiple possible answers with minimum number of operations, we have to return lexicographically smallest operation. So let's take cd this example, cd. Okay, so cd. Okay, so let's say what we can do. Okay, we can change this d to c in one operation, and we can again this change this d to c in one operation. So one possible answer is cc, and we are taking total number of operations here is 2. Similarly, we can change this c to d in one operation, and change this c to d in one operation. The entire string will be d. Okay, d. Here also the total number of operations are 2, but we have to consider this as our desired answer because this is lexicographically smaller. Okay, so we have to find the minimum number of operation and the lexicographically smallest string to get that minimum number of operations. Okay, now let's look at the constraints are not really important here. Caption dot length is 5 into 10 to the power 4. Okay, so what are the possible time complexities here, and understanding time complexity is very important because what is my solution is very close to time limit exceeded, or the total number of operations we can do in a given time limit. Okay, so that's why I am going to explain you why what till what time complexity we can go. So here n is 5 into 10 to the power 4, so order of n is definitely possible. Now here you can see that order of n into 26 square is also possible. My solution is around order of n into 26 square. This is also possible. Okay, now uh, I have given you the what could be the desired time complexity. Now let's discuss about the solution idea. Okay, let's discuss about the solution idea. I'm not going to discuss the brute force solution here because that will be very hard to get right. If we want to give the get to the brute force solution, you can think that approach I will take. If we remove the memorization from that algorithm, we will get our brute force solution. So let's jump into the recursion step directly. Okay, so let's say we are at the first character. Okay, we are at the first character. So let's say that is index I. We are at the index ith character. Now what is the last character we have taken? What is the last character we have taken? That is one point, the recursion parameters. And the third recursion parameter is that till what count we have got. Okay, till what count we have got. So let's call that count. Okay, this is a recursion state. I will now explain why we are taking this recursion step and how we'll jump to the next recursion steps. Okay, now let's say we have some string like this a. Okay, a. So initially our index is 0. Okay, index is 0, and we have not taken any character, so we can see that the last character is any hash. Okay, last character is hash anything, and the count is 0. Okay, the count is 0. Okay, now when we are at some character a, what we can do, we can take this character. Okay, we can take this character. So our index will be incremented by 1, and the last character we have taken is a because we have taken this character, and our count will be 1 because we are at one streak. Okay, we have one consecutive is. Now let's say we have jumped to the next day here. Okay, now here these two a's are same. Okay, these two a's are same, so that's why our streak will increase by 1. So this will be 2a 2, and then let's say we jump again our streak will increase by 1. So our this will be state will be 3a3. Okay, similarly let's say here instead of taking this a, let's say we are changing this to b. Okay, let's say we are changing this to b, so our index will be incremented by 1 2, but last taken character will be b because we have changed this a to b. Okay, and the streak will now end, the streak will now end at the previous a, and this will be 1 because we have taken only one b. Okay, I hope you get it. That's how we are making the transitions. Now, why it is important? The last character is important because this count is changing dependent on the last character. Let's say we are changing the current character to the last character, then the streak will increase. Okay, the streak is important, and last character is important because the streak is dependent on the last character. That's why with these three parameters we'll be able to solve this problem with recursion. Okay, that's why that this I could change from 0 to n. Okay, n, and this last character could change from a to z, so that will be 26, n into 26. Now here comes one interesting part. You can think that the count streak can increase till n, right? So you can think that the overall time complexity is order of n squared into 26, not n into 26 square. So that's how now the most important part comes, the interesting observation, that we can limit our count to 3. Okay, let's say our count is 3 or 10 to the power 3. That is not important to us. If count is 3 or count is 10 to the power 3, we can take the next character. Okay, let's say our count is now 1 or 2. Okay, now our count is 1 or 2. Let's say we are at this position or this position. Let me take another color. Let's say we are at this recursion step or this recursion step. That means that we can't go to this step, we can't go to this step. Why? Because our previous step will end to 1, our previous step will end to 1. Here we can't go to like 3b1. Why? Because our previous streak will end to 2. Okay, that's why if count is 1 or 2 or 0, that is one thing. If count is 3 or 10 to the power 3 or anything, that is not important. From 3a3 we can go to 4b1. Okay, from 3a3 we can go to 4b1. I hope you get it. That's why we can limit this value of count from uh, n to 3. Okay, n to 3 we are taking 1 2 3 and 0, so this will be 4 only. Okay, n into 26 into 4. Okay, I hope you get it. This is the recursion step, and you are thinking that this is the overall time complexity. No, this is not the overall time complexity. When I will go to the code, I will explain how that this will be again multiplied by 26. Okay, this is the overall idea. Now I will go to the code and will explain how the transition is happening. Okay, so let's come to the code. This is our recursion stage. Sorry, this is our recursion step. So this is our base condition. If we are at the end of the string, we are returning 0, and this is the memorization step, not important. And here now the first condition: if count is equals to 3 or n minus I is greater than equals to 3. So why it is important? So I have already told you now that we can take a new character, we can start a new streak only when our count is 3. This value is 3. Okay, this value is 3 only when we can take one new character. And another catch is there. Okay, let's say we have something like AAAZZ. Okay, AAAZZ. We can't start a new character from this string, this part. We can't start a new streak from this because we have only two characters left. We have only two characters left, so we can't start a streak from this I. So we can only start a streak when n minus I, the total number of remaining characters, is greater than equals to 3. So that's why this part is important. If count is 3 and the total number of remaining characters is greater than equals to 3, then we can start a new streak. Okay, now if the current character is equals to the last character, then we can continue the previous trick. That's why the gap is nothing but the difference between two characters and total number of operations to change the current si to this character. Okay, so if ch equals to lc, we are taking the gap and our count value is minimum of count plus 1 comma 3. So if count is 3, this will again be 3. If count is 1, it will be 2, or count is 0, it will be 1. Okay, I hope you get it. This is the part, and ignore this part, right? Ignore this part. Let me delete this. If ch equals to lc, we are incrementing the value of the count because we are increasing the streak. Otherwise, we are starting a new streak. I hope you get it. Now, this case will consider if the count is 3, or the last greater than 3 characters are remaining. Otherwise, if lc not equals to 26, why I have taken this case, I will explain later, but let's ignore this. If this condition is not satisfied, then we will go to this part. Okay, we will go to this part. This part is similar as this part is similar as this. I hope you get it. This is the recursion part, where we are recovering the minimum answer, minimum number of operation to generate a good caption. But our work is not finished here. We have to find the good caption, we have to find the lexicographical good caption. Here comes the catch. Okay, so we have to generate the answer from our dp array. So what we are doing here, let's say from this step, let's say this is a recursion step, and we are going to multiple steps. Okay, we are going to multiple recursion steps. Okay, now we'll also be maintaining one parent. Okay, we'll also be maintaining one parent. So what is the parent of this string, this state? What is the parent of this state, or you can say the child of this state? What is the child of this state which will be generating the minimum answer? So we for every recursion step, we are returning some value. We are returning some value from here to here, here to here. You getting it, right? So the step, the parent which will be the child which will be generating the minimum value will be the parent. Okay, what I'm saying, but I think you get it. The next step which is generating the minimum value will be the parent of the current state. That's what we are taking here. Parent of I, lc and ct will be, if the current answer is less than the answer, parent of I, lc, ct will be this one. Okay, I hope you get it. This will be the next step, the parent of the next step. This will be helpful when we will be generating the answer. Okay, I hope you get it. Now here, after our recursion is done, we will be generating our answer. So our first step will obviously be 0 comma 26 comma 3. Okay, so here where you are taking 26, because this will be our first starting character hash. So for denoting hash, we are taking 26. That's why this condition is important, because we'll only be going to the last character wala step only when our last character is not hash. Okay, I hope you get it. Now this part is for generating the answer. Okay, now while answer dot size is less than n, we are at each step we are considering that if our next step is -1 -1 -1, that means that we will not be generating any we are not going to any recursion step. That's when we'll having everything as -1, because we are initializing everything as -1. So if it is less than 0, we are returning an empty string. Okay, I hope you get it. This is the case for something like the last condition. Okay, last sample. Okay, otherwise our current will be the second character. Okay, because we are taking some character and we are going to the next step. That's why we'll append the current one plus a. Okay, the next this last taken character will be added to our answer, and at the end we will return the answer. Okay, this is quite nice dynamic programming problem. I enjoyed this problem thoroughly. If you have any doubt in any part of the explanation or code, you can always ask in the comment section. I will try to reply each and every comment. I will also provide the link of the code in the description box. You can check that out too. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you for watching.